let's shift to a couple of other topics. And I know one of them is just helping our clients understand what is AI. I think for many, it's sort of exclusively confined to generative AI. They've started to play with GPT. Maybe they're doing some proofs of concepts, but there's a lot of focus on generative AI. But there's a whole world of AI that sort of stair-stepped us to this point. The things that came out of the data science arena, machine learning, et cetera. And those are still going on out there. And I think it's an important topic to think about how they coexist and complement one another.
It's interesting. This is there's kind of two fronts to this. One is, if you ask people about tool calling or function calling, oftentimes they don't know what it is, right? And so this idea of LLMs being able to go outside of themselves and make calls to discrete pieces of code, whether it be a machine learning model, it might be SQL, whatever the case may be, is a very, very powerful concept. And so a question we all get, Mike, Shanti, and I all the time is, okay, we have all these machine learning models. Do we replace all of those? And the reality is, no, you don't. You can actually leverage those. And it's a huge opportunity for organizations to really augment what they're doing from a data science perspective, because we've suffered with this problem of how do we get our models and the output from our models to decision makers at the right time in the right place where they can actually make decisions that change the business. Well, there's no better way than through a large language model where I can talk to it, interrogate it, and we can tell a funny story if we have time. It was interesting. So we did some work with Travel Centers of America. And one of the questions, and we did some diesel pricing, right? So if you go buy diesel, little trivia fact, if you go buy diesel today from Travel Centers of America, that's all priced by algorithms Shanti and I and the team put together. Now, you can't blame us if the prices are going up because it's based on competitor pricing and inventory. But, one of the questions the team's always had is, why is this price $356 in Louisville? What's causing that? Well, it's because Love's down the street just dropped their price to $360, and they didn't have that capability. But that's very powerful to have that explainability with models. And so love this topic. And then this is a point Mike always makes. I'll turn it over to him. Is then you start to combine it with dark data that AI naturally does really well, and you start to have this power of bringing this data together.
Yeah, that's a great point, Andy. And the way that I think of this broad topic is to say, okay, all of this is machine learning. Anything that we've done, since with neural networks and other algorithms like that, it is machine learning. Now, the latest incarnation is large language models. Well, what's a large language model? It's just a machine learning algorithm that was trained on a large amount of language, right? It's easy enough. It's right there in the name, as it says on the tin, right? So is a large language model going to be good at predicting whether your customer is going to churn or not? And the answer is no, because it's a language model. It'll have an opinion about that because the language always has opinions, but it will not be good at predicting that thing. So if you have an algorithm that helps you decide where your next marketing dollar goes, does it go to this customer who may churn or that customer who may churn? A large language model is not the tool to ask, right? You ask your machine learning model that learned to predict which customers are going to churn, and then to make it, and those models are typically hard to use, right? There are lots of parameters and you have to have a data scientist use them. So you wrap that in a large language model that lets you easily take advantage of that tool. Hey, we've got $10, where should we spend it? Instead of, which subsystem do I integrate to the direction of the database? You just say, hey, where should I spend my next $10? And that's the 1-2 punch that's really working here. Enterprises understood this when they saw how dark data turned on and got really useful with the RAG techniques and language models. Then they started saying, well, hey, can I access databases, right? And we're getting a lot more of that. MCP brought some of that, and some text to SQL brought some of that, but really tool calling is what's actually made that work. Now, this third stage is saying, okay, how can we use our old, not necessarily old, how can we use techniques that were built before large language models?
No, we see that too, by the way, Mike. Yeah, it's
traditional.
Traditional, like machine
Classic.
learning's been around for 100 years, right?
Yeah. Absolutely. Yeah. So we tend to suffer from that. But anyway, these things end up complementing each other, right? To build out the whole. And that's the message that that enterprises are hearing. For a while they're trying to hit everything with the RAG hammer. because it seemed like that worked really well in 2023. So why not try it, on other things? Then MCP comes along and they go, oh, I can actually use things that aren't RAG. Good news. We can do some other stuff there. This area of using machine learning models, this is what's next.
I sat in a meeting with several senior executives from a very large, well known fashion retailer. And the sort of general view of AI there was, hey, let's just give it all of our data and it's going to, and Andy, I know you were part of this discussion, Shanti as well. Let's give it all of our data and it's going to figure out how to think about segmenting our customers and sort of the value life cycle of a customer. That it never was going to do that, but I think this is an example of where sort of there's the intersection of the possibilities of machine learning, classic, sorry, I used that word again, classic models and large language models. Maybe comment on that one a little bit, because I don't know that we actually ever got over the hump in that discussion, but it sort of stalled us out what their expectations were.
Yeah, and again, part of the challenge too is we talk about this all the time, is large language models are getting better and better and better. So they're encroaching on things they couldn't do well just a year ago or 2 years ago. So there's that also comes into this discussion. We can say, okay, well, large language models don't do this well today. Machine learning models do this really, really well, but that's a shifting landscape. So that's part of it. But I think what can happen, and it maybe in this particular case, is you start to fall into getting obsessed with the shiny object solution versus obsessing on the problem and really understanding the problem and saying, okay, what is the best solution for this? And really starting there. And it's very easy with everything going on in the market to go, wow, all we got to do is throw this into GPT-5, ask it a few questions. It's going to understand our context. And we all know that's not the case. And you can do these predictive kinds of modeling. We know that not always the case. So I think the key is, as you're implementing on your side, really understand the strengths of these different models before you start to implement, and then take an inventory of what you have.
Yeah.
You may already have things in your environment that you can take advantage of. And now the LLM just becomes an enhancer. It unlocks the value of those investments.
Well, in that example, there was a gentleman sitting in the room, another guy who sort of led the data science side, who, in essence, metaphorically raised his hand and talked about all of the models they've been working on that specifically addressed the questions that they were hoping that they could get a large language model to address.
Yep.
Yeah.
Well, we did work for a financial services firm, and we were coming in, we're ready to talk about customer lifetime value and segmentation. And as we're prepping for it, they give us some material to look at. Well, they had a customer lifetime value model that their statisticians had built, and it was good. I looked at the features in there. It's just how you would want to build this kind of thing. Been sitting on a shelf for 2 years. Nobody ever considered implementing it, even though they had it. They're like, well, I guess we're not going to try to sell them that. We know it won't go well. We should sell them some change management and be like, hey, if you build something, this is how you actually involve it and use it in your day-to-day.
Yeah, I was working with a financial institution, and they had built a fraud model, and it was brilliant. It was at least 5 percentage points better than anything they'd ever built. It was 500 basis points in their terminology, and it was so cool that they gave the big demo, and this guy hunched over a screen, and it was black with green writing, and he typed a bunch of dashes and slashes and escapes and pressed enter, and it said 92, and they cheered. And all the executives were like, okay, when's lunch? They just completely missed each other, right?
Right.
And so this is that magical part about unlocking that algorithm. Might have been beautiful, but if very few people can use it, then it's going to go nowhere. And look, so let me make a generalization here. See what you guys think of this. Large language models cannot do most anything that humans cannot do. In other words, they're basically trained on all the things that humans have done, and they're able to do those things faster and repeatably, and across a broader range of subjects. But they're not doing many things that humans can't do on their own. Now, an example of something humans can't do on their own is figure out the right way to, out of these 50,000 features, how to classify which of your customers are going to churn or not, right? We built these ML models that are superhuman in their capabilities, right? Superhuman means that they beat 98% of humans at doing a task. So these machine learning models can do that. The LLMs are not built to do that. They're built to do what people can do, only faster, right?
Yep.
So that's why these machine learning models will continue to persist, and in fact they'll get better. Now over time, language models will build their own ML models, right?
Absolutely.
And that will become how they operate. They'll build their own little neural networks to do these little side jobs. And in fact, there is evidence, if you look inside the brain of the LLMs today, there is evidence that they are already doing that inside their little brains. They're building algorithms for how to add numbers, how to do some basic things. You can see the little neural circuits going on inside. So they're already doing it to some extent, but they're not certainly doing it at the scale that Shanti is talking about, where you're doing a lifetime value calculation that's based off of figuring out what the features are and tracking the drift of it over time and locking into a specific way of using that algorithm, right? So it's continuing. In the language model world, we got to continue to respect our documents. We can't count on what the model was trained on to begin with. You have to bring in documents. You've got to bring in your own data. The model was not trained on that. You've got to bring in your algorithms because, again, the model wasn't trained around those. And you have to continue to respect the code that you've built, right? That's going to be valuable. And integrating all that is how you use AI to take it a step further.